Okay, so I'm James. I'm one of the co-organizers of the group, and today I'm going to talk to you about Elixir. Woo! Hooray! So who's done some Elixir before? You have? Well, that's a worry. You might know more than me. I thought I'd be the only one who'd done the Elixir.
About 2 years ago.
Okay, well that's okay, because I'll tell you maybe a little bit of a story. So,
Wow, that's so cool.
can you see how the slide transitioned? It's like this new sort of transition.
Are we 1% of the way through the presentation?
No, because there's some white space at the end. Shall I show you again? Wow! When I'm sitting down, it works even better, actually. But you'll see the reason for this is because there's a lot of code later, and it just seemed silly to put it in PowerPoint and then try and copy out of PowerPoint into the repo and stuff. So you'll see more the reason when we get past kind of the more PowerPointy bits, if that makes sense. So the story, right, is that I was at a kid's birthday party, as I often am because I have kids. And I ran into an old colleague who has a Elixir consultancy and is like the biggest fan of Elixir ever. You probably know him, there's only like one person who has an Elixir consultancy. Anyway,
Does he have kids as well?
he does, yes. Actually, my niece is his friend. He just talks about Elixir usually at kids' parties like a clown. No, he's really cool. And he talked my ear off about Elixir and told me how awesome it was, and it's been kind of on my radar of something I've been meaning to check out for ages and haven't got round to. So after that, I thought, okay, I'll check it out. And then we had a second speaker, and it turned out he couldn't present after all. So I thought, okay, why not? I'll give a presentation on it. So you can see that my depth of Elixir is not that deep. So you can ask me questions, and I'll do my best to answer it. So I think we're learning together here. So just set your expectations that this is coming from the learner's mind, let's say, rather than someone who's like done production Elixir for years. Besides, it's not that old. You can't do it for that many years. But even so, I've never written a production app in Elixir. However, the advantage is that I'm coming from it in the same perspective as you guys, right? Except maybe the two people who are probably Elixir experts who can point out and help throughout the presentation. Not heckle, mind you, help, right?
No, I just did a little bit playing around with it. Didn't write anything serious.
Okay, sounds good. That's probably good. Okay, so that's the story. So that's why I'm here. So, when you come to decide whether you're going to spend time on a new language, you kind of want to know, is there anything cool about it, or should you just be using whatever language you're usually using because you already know it, right? Why bother? So, what are the cool bits? And you've got to know a bit how it works before you can even decide that. And when would you put it to use? So, I don't know, you want to have a shallow understanding of a lot of things sometimes so you can choose which one you want to go with. So this talk should hopefully give you an idea on the Elixir front whether you would want to use it for various tasks in your future life. So what's good about it? So probably the coolest thing is that it's on the Erlang VM. So this is like 2 million connections per node, live sockets, etc. That sort of stuff, fault tolerant, distributed, kind of the sort of stuff that microservices dream of, but this is actually kind of built into the language and the VM underneath. So kind of nifty. It's used for World of Warcraft, Facebook chat, that sort of thing. Probably the most interesting thing besides the raw performance stuff is the actor model. So it's stateless, right? There's no state in this. It's a largely functional programming language. So it means that you have to do your state a different way, which I'll tell you about later. And it's to do with the actor model. So it's all about processes, which are kind of like nano services, if that helps in a post-microservice world. And yeah, you can spin things across different nodes and route them all over the place, and that sort of stuff all built into kind of the core of the language. So whereas other languages have got like int, this has got int too, but it's also got PID, which is like a process ID. And it's got all the stuff for multitasking, concurrency, actor model, that sort of stuff. So that's kind of the most exciting bit. It's functional programming, but not so pure that it like disappears in its own belly button, and academics like have arguments about how you should use io.println or whatever for hours and come up with fancy ways to do it. Not saying that that's not a good idea, but it's a bit simpler here. So you pretty much just do it like in more procedural languages. So no mutable state. The no monads, sorry guys, if you're looking for monads, Haskell groups around the corner, it's not here. But it's got pattern matching, which is really cool. So instead of writing if statements all over the place and that sort of stuff, you'll see later you can actually get away from most of that and have your interpreter or compiler do most of the work for you. So that's kind of nifty. Okay, so 2012, it's pretty young. It was made by a Rails core team member or ex-Rails core team member. So there's certainly some Ruby influence here, but you know it's a lot like Erlang as well. So it's kind of like a love child of Ruby and Erlang. It's got like the good looks of Ruby, but kind of the muscles of Erlang or something like that. You make your own metaphor. Richard's shaking his head. You do better. You do better. There you go. Okay, so anyway, it's quite a nice language to write in, quite pretty. But yes, it's got all this fancy stuff underneath. Now it is compiled, though. It's got a REPL and all that sort of stuff. So, and you can write your scripts and they compile on the fly to bytecode, which is Beam bytecode, which is the Erlang stuff. Okay, so how do you install the thing? See, now we come to more reason to be in a text editor, and I need to sit down to do this. So you can see this doesn't fit properly in my Vim window, but luckily we're going to start ourselves a REPL over here. So this is an Elixir REPL, and you can see what I've copied across. So if you want to install it, then you've got Mac is pretty easy, brew install, Chocolatey has got it. You can do it on a Windows installer as well, old school style, if that's how you like it. So I only tried installing on a Mac. I haven't tried on Windows, but it was super easy, no problem to get it up and running. So once you've got it up and running, or we don't need that, let's have a quick look at the language. So I want to show you some of the distinguishing cool bits, but we do have to do a little bit of the syntax first, otherwise the cool bits will just look too hard to understand. Okay, so we talked about that it's functional, right? So this means goodbye objects. You want to go like, let's make ourselves a string dot length. Do you think this is going to work?
Yes.
Fail. No, sorry, it won't, because it's functional programming. So we have to go string.length hello, which will work. So you don't have your data and your methods together. You have modules of methods, and then they work on your data structures. So, oh yeah, so no monads, right? You just IO put s as much as you want to print stuff out. Here we go. And it prints out the return value is the thing at the bottom. So it's actually returning OK as the result from that method, or that function. So far, so good. Not too crazy. That could be practically C# so far. But it's going to get weirder, don't worry. Okay, so also built in, like, you know, functional programming people are quite into lists and heads and tails and that sort of stuff. Yeah, and recursion. So this is all built in. So who can guess what this is going to do? Come on, Richard. You know you can do it if you work at it.
Definition array.
Looks like you're not getting the JetBrains license. It's going to give you the head.
It's all yours, of course, one.
And we're going to get the tail as well. So it does that sort of stuff, but it's pretty amazing. I mean, you can't do that in other languages in 2 letters without importing anything.
Why did tail not just give 3?
Because you get the head and the rest of the list, right? Anyway, you'll see more on that later, Richard. I'm sure we'll get there together. Okay, so like I was saying, we'll do a few basics. So did you think that was an array? It wasn't. It was a linked list, actually, because this is a different world out here. So rather than what you expect, these ones, it means that, of course, if you access the start, it's going to be really fast. If you access the end of the list, it's going to have to traverse all the way through. But hooking them up together like this one, so this is concatenating two of these linked lists together, is pretty fast because they're just like pointers between them. So the main list thing you work with is a linked list, but there's stuff that's like arrays, which is called tuples, also big word in functional programming world. So this one under the hood though just allocates like a chunk of memory and puts the things in it sequentially. So if we make ourselves a little tuple over here, there we go, got ourselves this tuple with 1, 2, 3. and then you can stick something into it. And again, right, the methods are outside rather than inside with the data. So we can stick Fred in the middle of the tuple if we feel like it.
Did that change it though, or is it?
So it's a copy. So if we look at tuple, it should be the same. Thank goodness it is, otherwise I'd be quite worried. It'd be all broken. Yo.
What's the difference between array and tuple?
So
Brackets.
you mean in terms of the...
In terms of
So that tuple's like, if you've got like 3 right here, we've allocated like 3 bytes or whatever the size is of these one after each other, whereas a linked list is like a pointer to each one along.
But it's not 3 bytes, it's a string.
In that one, so that one is using ints. I don't know how big the ints are in Elixir, but say they're, I don't know, 4 bytes or something. So that would be like the 9 bytes. Is that making sense?
Okay.
With each one. I don't know, maybe it's got a separator in between, but I think it's probably just got them sequentially laid out. And yeah, the syntax is different, curly brackets versus square.
Random access.
Yeah, so you can do random access because it's sequential in memory, like it's same speed to go to the last element as to the first element, whereas with a linked list, going to the first element is just as fast, but going to the last element could take ages if you've got a long list, because it has to go to the next node, find the pointer to the next one along, find the pointer to the next one along, etc. You guys know about linked lists, right? Yeah, okay. I don't know, last time I worried about linked lists was when I was running in C, and I was writing linked lists like, you know, from pointers, so.
Sometimes you call functions with brackets, sometimes.
Yeah, it's optional usually, I think.
Okay.
You can, like most of the stuff we've done already, I think. This one, I don't know, I think we can get away without it. Yeah, seems okay. Yeah, it's like Ruby in that regard. Again, like Ruby, we've got these things called atoms. In Ruby, they're called symbols. In C#, you'd use constants or something like that. So these ones, like the colon A, the colon B, C, etc. Those ones are just kind of something that you could use as a key in a hash or something like that, so that it's defined. It's only got one definition of it. There's no multiple copies of it in memory, and you use it as something that's kind of human readable as well, usually. So, for example, I'll show you the query down here at the bottom. This is using symbols. So if you're using link or something, right, you'd be doing it a little bit different with the dots in between or the built into language. Here, this is just using symbols and tuples implicitly to put together this kind of link-like query. So this one is the symbol atom, and here's like a closure that actually does something, I think. Now, just one step back, right? So I'll show you args. So it's really a linked list of tuples. But because everyone loves linked lists of tuples so much for arguments, for functions, and all sorts of things, then it's got this special syntax. So you can just go colon. So your key can just be with a colon, and you can leave out the tuple notation. So as a shortcut. That making sense? Kind of. It's kind of a neat way to tell, like, to pass arguments in. You know, like name parameters to methods. It's kind of like that. Or anonymous types, where you've got like the key. Yeah, maybe anonymous types is the closest, right? In C#, if that's where you come from. Then you make up your own structure which has got a key and a value. So this kind of thing is what we've got happening here.
Can you drop that syntax when you create that? Like when you create
Yeah, so you can do this A1, B1 syntax if you feel like it, and I think that's what we'll do for the rest. So you can make that 3 or something. Yeah. The other bit is just the fully explicit one, so you know what's happening. I don't think you'd use it usually. Okay, so regexes are there. Everyone knows about regexes. They're like first-class citizen in the language, like in Perl and Ruby and stuff. So it's quite easy to work them in. Now, onto hashes. So maybe I won't bother to paste that one across. If you put a % before your curlies, you get a hash. So you've got key, and now note we've got the symbol again. This is maybe closer to the anonymous types kind of thing. Right, you've got a key and a value happening here. For some reason in this example that I found, we've actually changed which way round the key and the value is, which is a little confusing, right? So usually you'd have a symbol be like, you know, temperature goes to, I don't know, 10 degrees or something, and rainfall. So make it a little bit more like you'd probably have real code. Goes to like, I don't know, 20 millimeters or something. Right, so it's key value basically. Okay, and then you can put it together to do something more fancy. So here we've got a linked list where we've got tuples with a key. So John is like the key of the tuple, and then the value is a hash, which has got keys of the name, the age, and the programming languages. So to represent something relatively complex, the syntax is fairly nice here. Keep in mind we're not like doing classes like we might be in other languages. So you could be representing quite a lot like this. Basically sort of fancy nested hashes to represent data. Okay, everyone following so far? Cool. I'm trying to maybe go through this bit quickly to get to the cooler stuff afterwards. So bear with me. You can make yourself a struct, which is kind of like a hash, except it's got arguments. I mean, it's got keys that are set. So if you make yourself a user, and then you try and create one. Sorry, you make the struct, right? So here we go. We've got ourselves the struct there. And now if we make our user here, yes, that's my real age, in case anyone's wondering. Yeah, but so that all worked, right? But if you add in a new key like sex male or something, right, it's going to give us an error because that key is not there. Sorry?
Because you're already made.
It's not that smart. So it only cares about the keys, that's all. So anonymous functions, no surprise, right? Everyone's got anonymous functions these days, even Java, I think.
Even how?
Yeah.
Yeah, it took like 2 decades, but it got there in the end. So here you go, you can have a function there. So you can see the anonymous bit at the end. So you go fn and then something pretty similar to other languages. Sing, yeah. So, sorry, go on. Oh, okay. So that's your little bit of a function in here. There you go. Now it's first class. You can pass it around, all that sort of stuff. So you can make your function, assign it to a variable. When you call it, though, you have to put a dot on the end of it, so that it knows it's a function, which maybe you don't in other languages. So you have to do $.10 or whatever. Just minor aside. But yeah, you can certainly pass them around. You can curry them and do all sorts of that fancy type stuff if you want to. But maybe you just want like a method. Everyone likes methods. I like methods. Do you like methods?
I like methods.
Cool. We're going to have one. Thanks, Richard.
You're welcome.
Going out on a limb there.
This is what I've been waiting for.
Okay, so here we go. We've got ourselves a module. You can't just make methods anywhere, it seems, in the REPL. You have to actually make a module to put it in. So module is like the thing before the dot. So if we go greet, and we'll do Richard, why not? Here we are. Hi, Richard. It's real code.
Good.
Well, that's so much better in Elixir, isn't it? So much more
Especially the
parallel.
exclamation mark.
Yeah, so you can see it's got string interpolation, very much like Ruby in here for sticking it in. So that's all good. And you can have privates as well. So if you say def p, you get a private rather than a public. And you can use shorter syntax, so you can go do colon and then you can drop the end. So kind of nice for one-line functions. So I don't know, maybe I'll run this one just for fun as well. Here we go. So it was the it's got tab completion here, which is nice. And then do the thing, you go, it calls the private. So kind of like you'd expect from an object-oriented language. That making sense? Public calls the private, It's all secret. You've got things like attributes, so you can mark stuff up. So this @callback is marking up an interface basically, and then we say that this JSON parser does this particular interface. So there's some more fancy metaprogramming. This is just like the basics, like you get in C# or anywhere else. And it's a dynamically typed language, though it's a bit tighter than Ruby, for example. And you can do static analysis if you put in these attributes, but you don't have to. They're optional. Okay, so that's kind of the basics. Now let's look at something more exciting. So have you done destructuring in JavaScript, that sort of thing? So this looks like destructuring, right? A bit, something like that, right? It's assigned our little A's and B's and C's like you'd expect it to. And then it starts getting weird, right? It's because its equals operator isn't actually an equals operator like you might expect. It's a match operator. Because you know, like, assigning's not a big thing, so it does something else. So here we go. This time it's going to match on the OK and assign the remainder to the result. So result will get, guess what? 13, right? So no surprise there. But kind of the nifty thing is, right, if you try and do it with one that failed, then you actually get an error at the compilation level. So this might seem a bit obscure, but you'll soon see that this actually is the basis for a lot of code. So for example, if you're opening a file, then you pattern match on the success result and the fail result and give it a different closure of stuff to do. So, oh yeah, heads and tails, no surprise. Heads and tails are well supported because you're probably going to use them a lot. So here you go. It's got quite neat syntax to do it, to split the head and the tail. But again, right, because this is the match operator, there's no head and tail here because it's empty. So you get an error rather than assigning null or something to it. Yep.
In runtime, would it be a runtime error?
I think so.
Yeah.
Yeah, I don't think, maybe you can use a static analysis tool, but I don't think it works it out usually in the language.
Does it have null values?
I think so. I haven't tried. Let's see. Yeah, it's got nil, like Ruby, but it doesn't work quite as Ruby's a bit like C and stuff, right? You can have things which are true and false that are just a value or nil. It doesn't work like that. It's much tighter. Like the nil kind of acts like a class rather than like just a nothing. If that clears it up. Okay, so you can also do other slightly more fancy stuff like pinning one of the things in your match. So if you've got a variable x equals 1, then it'll only match if this side is if this is a 1 over here, and then it'll assign 2 to the y. So it's just a way to say don't assign, like otherwise it'd be like the first one where you just assigned all the stuff across. So this one says you gotta treat that x as something you're not going to assign to. It's going to match or not. Okay. Any questions there? Cool. That's kind of the basis of heaps of stuff later. Okay, so control flow, you can do if and else and unless and stuff, but that kind of would be really boring because it would look like any old language. It's a little bit zoomed out so you can see the, okay, here we go. So we've got these condition statements. So you can say like if this left side evaluates true, then execute the right side. And this will come in handy later as well. So it's a very much shorter way of doing your conditionals versus like a if, else if type setup. So here's our demo module. We can go demo.greet and what have we got? So if it's altnet, right, hi everyone, etc. If it's empty. So this is one way of writing this very useful function. I'm sure you want to implement at home. No, but it's a easy way to do conditionals. But wait, there's more. Check out this. This is pattern matching. So that was kind of conditionals in a different way to usual, but now this is pattern matching at the language level. So rather than writing if statements like you might want to do in most places, this one has got two definitions of the same greet method, but one's got the altnet and one's got the empty, and it automatically calls through to the right one. So if we go greet empty, right, it says no name, and if we go greet, whoops, altnet, here we go. So it's actually helpfully doing it from the language, and we don't have to write an if statement. So that's kind of nifty.
And if it was something else?
You'll actually just get an error because there's no function that takes it. It's like, no way, there's nothing to handle that. So then, of course, because Fibonacci is like the canonical recursion, we can do that too. So that's based on pattern matching. So fib.fib, the first number is 1, the next one is 1, the next one, oops, it's going to be 2, etc. Okay, so you know Fibonacci, I don't have to go forever through Fibonacci's, right? What's the last Fibonacci? Okay, I think you get the idea, but the thing is, right, you want to go home one day, right? So it's got, you know, the clever version at the bottom, and it pattern matches for 0, 1, and then n. So n is, like, we didn't have an n for our greet before, basically, so that's why we got the error. But this one does handle it. So that's now, okay, this is the other bit I want to show you about the matching stuff. So here's our file. If you want to read hello.txt, right, and you want to handle errors, then you can give it 2 blocks to handle it, and it actually pattern matches. So if your response from the file open is good, then you get the body, you do whatever you want with the body. But on the other hand, if it matches an error as the argument, then you get the reason back. So then you can deal with that in your closure. So that's quite a nifty way to do it. Like in JavaScript or something, you could pass in like 2 different functions to do it, but this is kind of like built into the language with the matching rather than having to be like 2 arguments. So let's run it. Hey, look, we get an error because I didn't make hello.txt. So it matched the error one and put out my very useful message. Okay, so lots of weird stuff, slightly more weird stuff here. Okay, so you can put your conditions on your methods as well. You know, getting like a match theme or a, you know, so this is the same sort of deal again. Like it could match based on the arguments, or it can match based on the guard. So this one, it's got again two functions with just the same name, but one's got a guard and one doesn't. So that's how you're getting the difference between the true and the false. So larger than 2, right? So 1 is going to go into the false one down here, but if you put in like 10, right, then we're going to match into the n greater than 2 guard. The guards are not completely open to any code. There's some limitations on which ones you can use there. And you can only use like standard library stuff, or you have to do something fancy because it's kind of deep in the language. Oh yeah, other cool stuff. It's got kind of Unix pipe type stuff, but between methods. So let's see, so odd here, I'll just tell you about that. Does that look understandable? Anyone know what that does? Anyone want to guess? Basil? No guess? Okay, so.
What's the ampersand?
Good question, right? So we've defined this. So this gets the system, like the system function remainder, and then it gets the first argument that you pass in and sticks it off to remainder, and then it gives the second argument to remainder fixed as 2. So it's saying whatever you pass into odd, try and see remainder 2 of it and see that it's not 0. And this first ampersand here says, give me a reference to that function. So don't run it, just give me the function. So now odd works as you'd kind of expect.
Like C.
I think we have to do, I think odd dot, right, because it's an anonymous one, odd dot 2, right? So it works as you'd expect. You can call that remainder one directly probably. So if we go remainder 5 by 2, right, the remainder should be 1. So it's just calling through to that, but it's a fancy way you can write it with like the full closure and stuff, but this is a shorthand for it. Like you could write function x and then remainder x comma 2 if you wanted. But now this pipe stuff is quite interesting. So you've got a list 1 to 10 and then you filter it to be odd using our new anonymous function, and then you sum it up. And what it does is it passes the output of one to the input of the next one, just the first argument. So that works. Do you believe it should be 10? I don't know. Well, what you can do is stick it inspect in the middle of it and then see what's going on. So you know when you're usually poking through some sort of unpleasantly nested function, calling some other function, calling some other function with like all the brackets at the end, and you're wondering what's going on, then you have to break it all on multiple lines and put your debugger in or whatever. So this one lets you just stick like a io.inspect in the middle of it because it's just a pipe. So you can stick your inspection right in the middle. Makes sense? So here's our odd numbers, and then it's just summing them up at the end. So this is kind of nifty because you can then, I'll show you when we get to the web framework stuff, it's used quite a lot in my small experience of the web framework. Okay, streams. How are we going for time? Okay, yeah. So streams, it's got infinite streams, that sort of stuff. And files are streams, of course, but you can just make your own infinite cycle between 1, 2, 3 and start taking values from it. So it goes on forever.
What's exclamation mark?
This one here. Good question. In Ruby, this usually means it's a destructive operation. I'm not sure in Elixir. Okay, list comprehensions. So very functional programming. So this is doing the n by n of it. That one's easy. Everyone following that one? Yeah? Well, how about this one? This is a triple Pythagorean triples. And you see this one's got itself like a few generators. So it makes an A and a B and a C. And then it says, give me all the things where these two conditions hold true. And then just give me the values as a tuple at the end. And then our friend, the language, works it out for us. This is like why people go like, functional programming's the best. I like just made my my thingy here. I just made my list comprehension and it just did all my work, right? But I did read in the docs this wasn't very efficient, but I didn't put in the efficient version because it was like way too complicated to understand. So now you call it, okay, here you go, and it works out these, you know, like the triangle 3, 4, 5 things. But
They're both the same.
I know the version I didn't put in took that into account as well. It probably had like more filters and stuff, but you see, it's finding all the values where those filters hold, and then doing the collection, the collectible on it at the end. Okay, so if that wasn't enough, you can get yourself a abstract syntax tree of everything you feel like it. So pretend like some programmer's written length rather than length. This is a slightly contrived example, right? And it's in some programming that you want to run. So whatever you say quote do turns it into an abstract syntax tree for you. So then you can mess around with it and run it like you want to. So this is like eval, but with a lot more power. I mean, it's like the bit you do before you eval where you're building up the string and you don't include user input. Right, so here we go. So we've got length and we're going to call it on 1, 2, 3. And what's going to happen? Okay, so if you just run it, right, eval this one. So this is eval, right? We get an error because there's no length. It should be length, right? So okay, so we know it should be length. Let's change it to length. So we'll just get that abstract syntax tree and like poke it and change it over to length using put element, and then we'll evaluate it. So you can basically take a chunk of code and mess with it quite a lot before you eval it, or use it to write your clever metaprogramming, DSL type stuff. So it's kind of like all the other metaprogramming combined, because it chucks you to that abstract syntax tree level without needing all those other methods you have, like define method or something. You can just like make your syntax tree and run it. Okay, metaprogramming, no more on that one. That's it for that. Okay, so now the bit I did really want to show you was this whole actor model stuff. So say you want like 1,000 processes that put S the number multiplied by 2, right? Probably you want this all the time. No, you don't really. Okay, but the point is we just span up like 1,000 processes that did something really quickly, and it was really easy with just one like function here on the end. There's no messing around with all sorts of thread stuff, etc. And we had 1,000 of them, so they could have had your WhatsApp connections on the end of them or whatever else, or your World of Warcraft gamers or whatever you're developing here. Right, so there's slight variations on spawn. You can say spawn linked, and then when you get an exception, the exception propagates back to you again, back to your original process. But if you just spawn it without the linked, you know, they just go off, do whatever they want, they might die and no one cares. Spawn linked, you care. And task.start means that you can do async and other fancy stuff more than spawn. And you can come back and check results from it at some later point. Okay, so that's all background. Now, did you know that in our rep or whatever object we're in has already got its own mailbox? Is this sounding weird? Okay, let's send ourselves some messages. So here we go. We sent stuff to ourselves, and now we can see what's in our mailbox. Here we go. So hi, good day, bye. So flush prints it out and then clears it. So yeah.
Can you customize how the mailbox is working, like make it work like a priority queue or different
Ooh.
implementations?
I don't know. I'm not sure if that's how it's meant to work though. It's more for inter-process communication. So in my mind, it's more like kind of Unix sockets and that sort of thing, sending messages to each other. So keep in mind that basically every class in your app practically ends up sending messages to all the other ones. So it's kind of a simple queue, I think. There might be variations, but at the level I went, it was just first in. And you can also then process it. So, right, we flushed it out, right? So let's send these messages again. We'll just send the same ones for
What is self?
self. That's like this.
Process.
Yeah. We are PID 84. So we're in a process at the moment in the REPL. So we'll send ourselves some more messages. Great. And then if you want to process messages, we use like that same sort of syntax, pan and matching with a closure kind of thing. So if we've got hello or bye, let's paste those ones, right? So we got bye printout at the end, which is because we matched the bye. That was one of the messages that came in. So we didn't get a match on hello because there's no hello there, so that code didn't execute.
Is it flushed there as well?
And so it has flushed only the one that it's processed. The other two were still hanging around there. So this is starting to get into the core of the communication mechanism. Okay, so now you might have been wondering how you can store any state in this whole affair, because there wasn't any way yet in this presentation. Everything just, you call something, that was it. So the way you do it is kind of quite different, right? So you start storing things in these processes. So this one, I'll talk you through it. This is kind of an explicit version. There's like shortcuts for all this stuff because you do it all the time. So the start link stuff says make us a new process and call this method down here and give it just an empty hash as the starting argument. Right, so this process spins off and sits there looping away, and this loop has got to receive like we saw before. So if you send it a get with a key, it's going to send you back a message of the value. So from our main process, if we get a key, it'll send a message back to us, which is the value that it's pulled out of the hash. And then if you want to change something, you can put a key in a value, and you don't need to say who you are because it doesn't send you back anything. So this is our state is now stored in this process based around this map. So this is, let me just paste it in and you can see it working. So here we go, we've defined our module. Now we're going to run it, we're going to pattern match that it succeeded with the OK, and we'll get the PID back, which is the processed identifier. Okay, so we've got that all well and good. So what are we going to do? We can send it a put first. So we'll say altnet is cool. Just a little bit of marketing here, secretly, subconsciously. Okay, so we've sent this message. Let's see what happened to us as the main process. Okay, nothing happened to us. We got no message sent back because put, if you have a look over here, doesn't send anything back. Sorry, up here, right? But when we go ahead and do a send of a get instead, we have to pass in our own PID so that it can send us back a message. So here we go. We send that one, and we've done the get, but it didn't actually return the value, right? As you might have expected, it actually sent it as a message. So if we do flush, we got the is cool back as our message in our message queue. So this means you could be, distributed across time or async or whatever else, or distributed across different nodes, because it's not like an RPC call, it's a message. Okay, so you can do it twice and you'll get 2 back. Okay, you get is cool twice, as you'd kind of expect. There's shortcuts for this. You can register your process with a particular name if you want. If you think it's important, you can call it like KV, your special key value store. But because this stuff is like the bread and butter of writing Elixir, then there's all sorts of wrappers for this. So this is effectively the same code that we had before, this agent here, but it's doing it. See, it's got the same hash. You do stuff with the map, but it's kind of got all the plumbing already done for you, and you're passing in closures for it. Okay, and then you go a bit more abstract again, and there's generic servers rather than agents, and these ones let you do more async stuff and more fancy things. But again, it would be a service that holds some sort of state for you probably that you're using this for, and you're sending it gets or puts or whatever verbs you feel like. So yeah, this stateless business, right? So this is the way you do it. It's like these tiny little nano services that you build up, and they all communicate with messages. So it's like a message-based microservice architecture, and you can spread it across whatever nodes you want, etc. And it's all built into the language. And when you make an app, you do maybe get to the next bit, right? If you're making a non-web app, then you have like some sort of registry for your services, and you have a supervisor that that starts them up and stops them, and if they die, recycles you a new one up, and you can build a little router that sends it, shards it, and does it to different stuff. So it's almost like,
But everything's still in memory, right?
But it's these ones, yeah, you can write stuff out to disk. So like the web framework's got this thing called Ecto that's like the OR, well not OR mapper, but the database access stuff. But yeah, all in memory so far. So that's kind of how you build up your app. It's got all these little ones, and your app spins up all these services at the start, and they get supervised, and then they all chit-chat to each other to do whatever you want it to. Any questions at this point?
You say
Yep.
it talks between different computers?
Yeah, so you can spread it across computers. Of course,
And
you've got a latency to worry about.
But who will be shuffling?
Sending it to,
Sending
yeah.
the data?
You write like a little router that says which one you want to send it to. So you could send, like requests for customers A to C to this node, D to whatever to the next node. Is that what you mean? Like if you're sharding it,
Can it
or
be done automatically for me?
I think you can distribute it at a basic level automatically. Yeah, I didn't really dig into it, but it looked like you had some sort of shared secret that you gave to all your instances of
Isn't that
Elixir.
part of the Erlang?
Yeah, so this is all the same as Erlang. Yeah, So I think, yeah, it's just, you could be running Elixir on top of it, or you could be running Erlang. So it's all Erlang VM level stuff. Okay, it's got some build tooling. So kind of combination of Saki, MS Build, whatever you want to say, whatever you come from, all the build tooling and the project type stuff. So let's see, let's quickly do this. Okay, let's enter. Here we go. So it made us stuff. It made us, I'll show you, it made us like a shell project basically out of the box. It comes with tests because it's a modern language and testing is, whoops, let's go into the project first. Testing is pretty basic these days. So looks a lot like other test runners, but it's nice, it makes stuff for you out of the box. Okay, so that's in your command line one, you'd then start configuring it. It's got environments and things out of the box, and you'd hook up your different processes. Okay, so now a very, very quick look at Phoenix, which is the web framework. So that was command line tools. I'm not going to teach you much Phoenix in the last like 5 minutes of the presentation, but just to give you a taste, it's a lot like ASP.NET, MVC, and Rails. So to install, you use like this package manager called Hex. So, and then you just say pull the thing down. It installed pretty easily. I haven't used any other bits of the package manager, but for this anyway, installing Phoenix was pretty easy. Then to make your app, you use Mix again, but use Phoenix, like the Phoenix thing we just installed. And then I used MySQL for the database because I had it installed already. But it's a bit like Rails in that it needs a database to do most stuff. The Ecto business is to do with migrations and database creation and setup. So you call that one to set up your DB. Okay, so to save time, we're not going to run all those. I ran them already, but we are going to start up the server. So I have one prepared. Here we go. And it's got a server called Cowboy, which is serving on port 4000. Let's find ourselves a Chrome. Okay, so, oh no, we've already jumped ahead. Let's go back to the start. Here we go. Welcome to Phoenix. Very exciting. I'll show you the code now. Let's go over here. Hey, look, it's in a different copy of Vim. How cool is that? Just like PowerPoint. Okay, so this one over here is the routing. You've probably seen this sort of stuff all over the place.
It's a Nancy approach.
Like standard, looks like Sinatra, looks like Rails, looks like, you know, half a dozen other frameworks. So you say, okay, you get the root, you go to the page controller, you run the index method, and it's got scope. So it's totally Rails actually. Oops. Then if we have a look at the page controller, this is where we've got this pipe stuff being cool. But first, the one we just ran was index. So it's got parameters we're not using, and it's just rendering a template called index. And the template I'll show you over here. Right, doesn't do very much. HTML, it's got a bit of markup in it so that you can run code and stick variables into it, very much like all the other web frameworks. Then you can see I've got one which has got index with an error, and this one gets the connection. It uses the pipe to add more stuff onto it. So the connection object gets more stuff added, and then it renders at the end. This is like a problem that you find in other languages, right? How do you add all the stuff that you want to do in a neat way before you call render? In Rails, you call stuff that kind of works a bit more magically in the base class, whereas here you can see it's all just on the connection object explicitly. So you can see this one with errors. It's not super exciting. Here you go. So it's got some flashes and some errors up here. But the cool thing is using this pipe operator as a neat addition to the framework. And the last one, this one takes a parameter in name, just a usual, get parameter, and then it uses index with params as the template. So this one over here has got the @name coming through. So if we run it, index with name, with params, okay. With alt.net, yeah, it says welcome to alt.net. So I haven't dug much further than that, but it seems like a pretty classic web framework, and it's got tests as you'd expect for for any modern framework at a convenient sort of level. Okay, so that was a lightning tour. Let me go back to my presentation deck. Here we go. We've seen all that, and there's a few resources there. So if you want to poke through what we've seen tonight more, you can see it's on my GitHub. And then the two places I really looked were the Elixir and the Phoenix getting started stuff. The docs are actually quite good. I was impressed. They're quite well set up and lead you through learning the language and the framework. Cool, that's it. Any questions?